draw a cubic graph. Here we are still in calculus, so I will be doing a whole lot of calculus examples on how to find the gradient of the graph, how to find your x and y values, and how to know where the graph is increasing and decreasing. All right, so when we have the derivative of a graph, it's the gradient. So we are given this formula: 3 cubed minus 2x squared minus x plus 2. This is the equation of this cubic graph, and we are asked to find the gradient. For us to find the gradient of this cubic graph, we simply just have to derive. So when we derive, we indicate by this that this is the derivative of this original formula, so or equation. So when we derive, we say 3 times whatever we have here. So when we don't have any number before x, which means we have 1, right? So 3 times this 1, and that will give you 3, right? Then we say this number, which is the exponent, which is a 3, we minus 1. Then we get 2, right? So here we do the same thing. We say 2 times this. Here it was 1, but here it's 2. So it's 2 times 2. So it's 2 times 1. It's 2 times 2, sorry, yeah. 2 times 2 times negative 2. Then we get negative 4. And then we say this 2 exponent, we minus 1 from it, and then we get 1. Remember, we do not write 1, so it will just be x. And then we come to this x, we say this, it's a power of 1 minus this negative 1, it would still be 1. And then we have this x minus is 1x minus 1, it's 0, right? So this one will automatically be times 0 because there's no x. So the power here is 0, obviously. So this will be times x, right? So it will not have anything. So this is the derivative. This is the gradient of that graph. When you ask for a gradient, they're asking for the derivative. That's what you have to know. That is the gradient. So let's look at this graph. So we have this graph, and this is a cubic graph. Now, when they ask you a question, where is this graph? Maybe let's say, where is your gradient negative and where is your gradient positive? Now, and where is your gradient 0? So when this graph is going down like this, you see it's pointing down, the gradient is negative, and from here going up like this, the gradient is positive. So when you are asked where will the gradient be 0 or where will the gradient be a negative, when you go to your graph, this is how you interpret it. This is going down, so this is negative, and this is going up, so the gradient here is positive. So at your turning points, here on the turning point, your gradient should be 0. So here you can substitute this value of x, which is 1,55, into this equation, and you'll get 0. 1,55 squared minus 4 into 1,55 minus 1, and that is 0,0000. You see, yeah, that is 0. So here our gradient should be 0. So now what we are going to explore is how to find the x values using our gradient, which is the first derivative. That's what we use to get x values. Now let's look at this equation. We're having this equation of a cubic graph. There also, remember, we say 3 times this 1 here. That will give us 3, and then 3 minus 1, that's 2. Then 2 times this negative 2 here, that is give us 4. Then we say 2 minus 1, that's 1. Then this 1 here times this 3 is 3. 1 minus 1, that's 0. So this is automatically times 0. Then this is our first derivative, so this is our gradient, right? Now we want to find the x values. When we want to find our x values, we were given here how much is the gradient, right? How much is the x value? What is the not what is the x value when gradient is 1, right? So where our gradient is 1, we have to know what our x values are. So we are going to equate this gradient to 1 because this is equals to 1, right? It told us the gradient is 1. Now we have to find the x values when the gradient is 1. So this will go this side, it will become negative. This is a derivative, remember, so that will be 0. We will solve this and we have a quadratic equation, so we will use the quadratic formula. Negative b plus or minus square b squared minus 4c all over 2a. That is the quadratic formula that you will be using in this instant. So you will get this x values as negative 2 over 3 and x will also be 2. So here we can do an example. So here, for which values of x is gradient equals to 4? Remember, the first step we have to make is to find, oh, sorry, sorry guys, we have already derived, so no, we haven't derived. We are going to say f at x, you have to derive, right? So we say 3 times this one here, that will be 3 x3 minus 1, that will be 2, and then this 2 times this negative 2, that will be negative 4 x2 minus 1, that is 1, and then that is minus 1 times 3, it's 3, and then this is 0. So this is the derivative. So we are going to equate this to 4. 4 equals to 3x squared minus 4x minus 3. Remember these steps clearly that you have to derive first when you get this so that you can equate this properly. So we have 3x squared, this will be 0, we are taking it that side, minus 4x minus 3 minus 4. So the next step here is to combine this 3 squared minus 4x, negative 3 minus 4, that is negative 7. So we have a quadratic equation here. So we say negative b plus or minus b squared minus 4ac all over 2a. So this is a, this is b, this is c. You just take them into this equation including their signs. This is negative, this is also negative. So x is equals to 22,33, or x equals to negative 1. But if you decide to factorize and not use the quadratic formula, then here it will be 3x and this will be x, right? So what needs to happen is that this bracket needs to give you this middle term, right? So that's minus 7 and then plus 1, because when you say -7 times the 1, that will give you a -7. So this should give you this outer, and this one's inside the brackets should give you the middle term. 3 minus 7, it's a -4. So if you have factorized, this is where you have to be. All right, here we are going to do where is the graph increasing and decreasing. Here you have a graph. This is A, this is B, this is C, and D. Remember, here when it's going up, it's increasing, and then from here, this is where we experience a decrease. Now we have this equation here. Determine x values where the graph is increasing, and this is the equation. So the first thing you have to find the derivative of this equation. All right, now the next step is to turn this into an inequality. So turning it into an inequality, it's 0 here, and then 3x squared minus 6x minus 9. You still remember that we have to say 3 times 1, it's 3. 2 minus 1, 3 minus 1, it's 2. And then you say 2 times 3, it's 6. 2 minus 1, it's 1. 2 minus 1 is 1. Then you say 9. 1 times 9, it's 9. 1 minus 1 is x. This 8 is times 0, so it's 0. Then we have to equate here. I made a mistake with this equals to sign. You have to equate. Now this is an inequality. So when you have an inequality like this, what you have to do, what you can do is use a quadratic formula. So you're just going to go on your calculator and do this as an inequality. This is A, this 3 is A, this is B, and this is C. So when you have an inequality question like this, and you have these two values, right, that you got, this is -1, sorry, this is -1, so I got these two values. You put x in the middle. The one that is negative, you do this sign facing this direction. This is a -1. The one that is positive, you do a direction doing like this. This is a parabola. Remember, if you watched my functions video, this is a parabola, right? Then here is -1, there is 3. So this part represent this part represent this. This is where x is smaller than 0 this side, x is bigger than 0 this side. So we have identified the x values where the graph is increasing. So when it's increasing, you write it like this, and when it's decreasing, that sign will go that way. So this has to be bigger than 0. You find where this graph is bigger than 0 because we are increasing. Try to find a good app. I will share the one that I know that is quite good that you get on Google Play, that will help you get a lot of questions where you will be practicing this in your exam. I'll remember the name. All right, now we are talking about a tangent. A tangent is a line that touches the graph once. So we can have a line that's going like this on the graph, which is a tangent, right? So the equation of a tangent equals to y equals to mx plus c, because the tangent is a straight point. Name gradient at point of contact between the graph and the tangent equals gradient of the tangent. So the gradient of the graph where that tangent touches, if it touches here at the turning point, then because the gradient is 0 then which means the gradient of the tangent is also 0. If it's where the graph is increasing or maybe it's in positive, it's that, well, the gradient is 4 there, which means the gradient of the tangent is also 4. So the gradient of the tangent is the same as the gradient of the graph at the point of contact. That's what you have to remember. So here we have an example. We are given this cubic equation of this cubic graph, and we are asked to determine the equation of a tangent. I didn't complete it, where x is 3, right? There x is 3. So we have to know what is the equation of the tangent where x is 3. Now this is the equation. We have to derive to find the gradient. This is the gradient. So at this point where the gradient is this way, x is 3, right? So we are going to substitute 3 into this equation, right? Because we're going to substitute x in this gradient. Substitute 3 to see what is the value of the gradient. So the gradient is 12, where the value of x is 3 on this graph, right? So this 12 will also be the gradient of the tangent. Let's repeat it. You are asked to find the equation of the tangent where x is 3. You take the original formula, you derive. After deriving, wherever you see x, you substitute 3. Because at that point where the tangent is touching the graph, x value is 3. So you just put 3, and then the answer you get is the gradient at that point is 12. So that is this gradient of the tangent as well. So we know the value of x there. Now to get y, we substitute x into the original formula. Which one is the original formula? That long one before the derivative. We substitute that value that we have as x, which is 3. Then we'll find y at that point. Y is 4. So y equals to 12x plus c, right? We have the value of y and x at this point, which is 4 and 3. We substitute to get c. Now we take this, we times this, take it this side, we'll get, when we take it this side, it will be 4 minus whatever we get here, we'll get 32, and then that's the value of c, and this is the equation. Y equals to 12x minus